Welcome to Philosophy Maths, fighting problems one step at a time.
Hello and welcome to Philosophy Maths. Today we're having a lesson on factorising quadratics, a harder case. Let's have a look at an example. So we've got here 2x squared plus 7x plus 3, and we want to try and factorise this quadratic here. Now the reason this type of quadratic is harder to factorise than most quadratics is actually because of this 2 here, the number next to the x squared. Now if this 2 actually wasn't here, we'd have a much easier quadratic to factorise. And I've actually explained how to factorise these types of quadratics in a previous video. I'll put the link to that in the description below. However, because we have got this 2 here, we can't use that method at all, so we're going to need a completely new method. So here's how we proceed in this case. We take the number next to the x squared, which in this case is a 2, and then we take this constant term here, the 3. The constant term is just the number that doesn't involve any x's like these two do. What we do with these two numbers is we multiply them together. So in this case we get 2 multiplied by 3, which gives us 6. Okay, we're ready to use our new method now. We need 2 numbers that multiply together to give 6, and those same 2 numbers need to add together to give 7. Okay, let's start by thinking about numbers that multiply to give 6. So we've got 1 multiplied by 6 is 6, and we've also got 2 multiplied by 3 is 6. Now the question is, which one of these 2 pairs of numbers adds together to give 7? Well, that's clearly 1 and 6, because 1 plus 6 is 7. Okay, so we've now found our 2 numbers that multiply to give 6 and add to give 7. And we're going to use these 2 numbers to actually rewrite this expression here by splitting up this middle term, 7x. We'll do that in the following way. So we'll start by copying down this 2x squared. But instead of writing plus 7x, we're going to write plus 1x. And then we're going to write plus 6x. And let's not forget the plus 3 at the end. So this expression here is exactly the same as this, except instead of writing 7x, we've just written plus 1x plus 6x. And that's fine because they add together to give 7x, so we haven't changed anything really. Now the reason this is useful is because we can now split this into 2 parts. We'll split it into the first 2 terms and the second 2 terms. Now the way we proceed is we actually want to factorise each of these 2 pairs of terms separately, using a common factor. Now if you don't know how to factorise an expression using a common factor, I've got a video explaining how to do that, links in the description below. Okay, let's start by factorising these first 2 terms here. So what's the highest number that goes into both 2 and 1? Well, that's just a 1, so we don't need to write that. We can move on to our x's now. What's the highest power of x that goes into x squared and x? Well, that is just x. So that is our highest common factor of 2x squared plus 1x. So we can now open our brackets, and inside the brackets we need something that multiplies by x to give 2x squared. Well, we're going to need a 2, because we've got this 2 here. But 2 times by x is just 2x, but we actually want 2x squared. So we're going to need another x, so that 2x multiplied by x is 2x squared. We can now go ahead and copy the plus and move on to this second term. So something here needs to multiply by x to give 1x. Well, that is just 1. Okay, so we now factorise these first 2 terms here as x multiplied by 2x plus 1. So we can now move on to our second 2 terms. So we're going to go ahead and copy this plus down in the middle. And now let's look at the numbers. What's the highest number that goes into 6 and 3? Well, that number is 3. Now in terms of the x's, there's actually only an x in this first term here. There's no x here, which means that x is not a common factor of these 2 terms. So we can go ahead and open our brackets now. Here we need something that multiplies by 3 to give 6x. Well, 2 multiplies by 3 to give 6, which means that 2x multiplies by 3 to give 6x. Let's copy the plus down here. And now we need something that multiplies by 3 to give 3. Well, that is just 1. Okay, what you'll now notice is that 2x plus 1 actually appears in both the 2 terms here. So the way we finish off our factorisation is we actually factorise this whole expression using 2x plus 1 as a common factor. Okay, let's go ahead and do that. So 2x plus 1 is our common factor. And now we can open our brackets. Now inside the brackets, we basically just have everything that's left over if we remove the 2x plus 1s. So everything that's left over in the first term is just x. And then the second term, everything that's left over is just plus 3. And that completes our factorization. So if we factorize this expression, we get 2x plus 1 multiplied by x plus 3. So in the second example, we've got 5x squared plus 8x minus 4. To factorize this, we're going to start in the same way as we did before. We're going to take the number next to the x squared, which in this case is a 5, and we're going to multiply it by the constant term here, which in this case is a minus 4. It's important to note that minus there. So we're going to multiply these two numbers together. 5 multiplied by minus 4, and then we get minus 20. Okay, we now need two numbers that multiply to give minus 20. And those same two numbers need to add to give plus 8. Okay, let's start by thinking about numbers that multiply to give minus 20. Well, if two numbers multiply together to give a negative number, that means that one of those numbers has got to be negative and the other one has got to be positive. Okay, so the first pair of numbers that multiply to give minus 20 is plus 1 and minus 20. But we could also have minus 1 and plus 20. We've also got plus 2 and minus 10, and minus 2 and plus 10. We've got plus 4 and minus 5, and we've got minus 4 and plus 5. And that completes our list here of all the numbers that multiply to give minus 20. The question now, which one of these pairs of numbers adds together to give 8? Well, if we check through our list, we see that that's actually going to be this one here, minus 2 plus 10, because those two add together to give 8. So I'm going to go ahead and circle those. And we're going to use these two numbers to rewrite the original expression by splitting up the middle term, 8x. Okay, let's go ahead and copy the 5x squared to start with. And now, instead of writing plus 8x, we're going to split it up. So we're going to write it as minus 2x, and then plus 10x. Now let's not forget the minus 4 here at the end. So just like the previous example, we haven't actually changed the expression at all, because minus 2x plus 10x is 8x, so we haven't changed anything. Okay, to proceed, we're going to split up this expression into two. And what we're going to do is factorize each of these two pairs of terms separately using a common factor. Okay, let's take the first two terms and let's try and factorize those. Let's look at the numbers 5 and 2. What's the highest number that goes into 5 and 2? Well, that is just a 1, so we don't need to write that. Okay, let's move on to our x's. What's the highest power of x that goes into x squared and x? Well, that is just x. So this is the highest common factor of these two terms here. So we can now open our brackets, and inside these pair of brackets, the first thing we need is something that multiplies by x to give 5x squared. Well, that's going to be 5x, and then we're going to copy the minus, and we need something that multiplies by x to give 2x. So that's just going to be 2, so that 2 times x is 2x. Okay, let's copy this plus down, and now we're going to focus on factorising these second two terms, 10x minus 4. Let's start with the numbers. What's the highest number that goes into 10 and 4? Well, that number is a 2, so we're going to write that here. Now you'll notice there's only an x in this first term, there's no x in this second term here. So x is not a common factor of these two terms, so we're now ready to open our brackets. Okay, the first thing is we need something that multiplies by 2 to give 10x. Well, 5 multiplies by 2 to give 10, so 5x multiplies by 2 to give 10x. Let's copy the minus, and now we need something that multiplies by 2 to give 4. Well, that's going to be 2. Okay, what you'll now notice is that this 5x minus 2 actually appears in both the two terms here, which means that 5x minus 2 is actually a common factor of this whole expression. So we can now factorize this whole expression using that common factor of 5x minus 2. So let's go ahead and do that. So we've got 5x minus 2 is our common factor. And now we can open our brackets. And inside the brackets, we just have everything that's left over in this expression if we ignore the 5x minus 2's, because that's our common factor outside the brackets. Okay, so what's left over in the first term is just x if we ignore the 5x minus 2. And then what's left over in the second term if we ignore the 5x minus 2 is just plus 2. And that completes our factorization. So we've got 5x minus 2 multiplied by x plus 2. Okay, thanks for watching this lesson on Factorizing Quadratics, a harder case. See you next time. Have you suffered from a maths-related injury in the last 4 months?
You're in the right channel. Welcome to Philosophy Maths!
Hi there, welcome to Philosophy Maths. Today we're having a lesson on Factorizing Quadratics, a harder case. I'm going to do that again. A harder case. Okay, what you'll now notice is that these two terms in the